So, let's go. Right now, while you're sitting there, there is a machine inside the atmosphere of the sun. Not near it. Not pointed at it through a telescope from somewhere safe. Inside it. Flying through the outer layers of a star, surrounded by plasma hotter than anything you could ever stand next to, and it is still working. It still phones home. And every time it does, it sends back something we were not ready to understand. We built it, we named it after a man who was laughed at. And then we threw it at the one thing in the solar system that could erase it without noticing. These are 10 of the most terrifying things the Parker Solar Probe has found out there, and each one is stranger than the last. Number 1, touching the sun. Forget everything you picture when someone says space probe. You're imagining something drifting in the dark, taking pretty photos from a polite distance. This is not that. On December 24th, 2024, Christmas Eve, while you were probably arguing about dinner, this thing dropped to 3.8 million miles above the surface of the sun. That sounds far. It isn't. If you shrank the entire distance between the sun and the Earth down to the length of a football field, Parker skimmed in to about the 4-yard line. It went into the fire, and it did it moving at 430,000 miles an hour. Let that sit for a second. That's the fastest any object built by human hands has ever moved. Fast enough to cross the entire United States in about the time it takes you to tie one shoe. Nothing we've ever made has gone that fast, and it's doing it on a loop over and over, falling toward a star and whipping back out. The only thing between the spacecraft and total destruction is a shield about 4.5 inches thick, the thickness of a paperback. The front of that shield glows at around 1800 degrees Fahrenheit, 1000 degrees Celsius, hot enough to melt steel, while the instruments tucked behind it sit at roughly room temperature. Cool enough that you could rest your hand on them, a paperback's width away from something that would vaporize you. Here's the part that gets me. When it made that closest pass, it was completely alone. Too far, too fast, out of contact. The people who spent years of their lives building it could do nothing but wait. For 2 days, nobody on Earth knew if it had lived or died. No data, no images, just silence and a star. Then, on December 26th, a single tone arrived. One beacon signal, alive. You think this is a video about a machine. It's a survival story and it's still happening. Number 2, the switchbacks. So it got close. Closer than anything ever had. And the first thing it found out, there was something nobody could explain. The sun's magnetic field up close is not calm. It's not a smooth set of lines arcing gently into space like the diagrams in your old textbook. It's thrashing. Parker flew into regions where the magnetic field suddenly whips back on itself, bends into a hard S shape, reverses direction completely, then snaps forward again. Scientists call them switchbacks. Picture a garden hose, except the water is plasma and the hose is cracking like a whip 1,000,000 times over, and they're not rare. Close to the sun, Parker found them in dense clusters packed together everywhere it looked. The closer it got, the more violent the sun became. Now here's why that matters and why it might keep a physicist up at night. There's a mystery about the sun that's been sitting unsolved for more than 50 years. The surface of the sun is hot, around 10,000 degrees Fahrenheit. But the corona, the wispy outer atmosphere above the surface, the part Parker is flying through, is hundreds of times hotter. Millions of degrees, that's backwards. That's like walking away from a campfire and feeling it get hotter the farther you go. It makes no sense, and it has embarrassed our best models for half a century. The switchbacks might be part of the answer. All that snapping and reversing dumps energy into the corona, and that energy could be part of what's cooking it to impossible temperatures. We're not certain yet. But for the first time, we're inside the thing, watching it happen, instead of guessing from 93 million miles away. The sun isn't a smooth ball of fire. It's a thrashing magnetic machine, and we just stuck our hand inside it. Number 3, where the solar wind is born. There's a wind blowing past you right now. You can't feel it. You'll never feel it. But it's there, and it never stops. It's called the solar wind, and it's a constant river of particles streaming off the sun in every direction at over 1,000,000 miles an hour. It washes over the Earth, it shapes the tails of comets, It carves the edge of the entire solar system. The man Parker is named after, Eugene Parker, predicted it back in 1958, and people thought he was wrong. They mocked the idea. He was right. But for decades, even after we knew the wind was real, we didn't know where it actually came from. What launches it? What gives a stream of particles enough of a kick to escape a star's gravity and blow clear across the solar system? That was the question. That was the whole reason this probe exists. And Parker found the birthplace. It traced the fast part of the solar wind back down to specific spots on the surface, places scientists are calling magnetic funnels, dark little openings in the sun's magnetic field where the wind comes pouring out. Combine that with the switchbacks, and you start to see the engine. You start to see how a star breathes. Think about what that means. The thing that shapes our entire neighborhood in space, the wind that's been blowing over you, your whole life, and your parents' whole lives and every life before that. We just found the place it's born. We're standing at the source. And the source is louder and stranger than anyone expected. Number 4, driving through an eruption. You'd think a spacecraft this fragile would spend its whole life trying to avoid the sun's worst moods. It doesn't. On September 5th, 2022, Parker drove straight through one. The sun, every so often, throws up. It launches a coronal mass ejection, a colossal cloud of magnetized plasma, billions of tons of it, fired off the surface at insane speed. These are the things that, when they hit Earth, knock out satellites and light up the sky and scare power grid engineers half to death. And Parker flew into one of the most powerful ones ever recorded, on purpose. Well, it was there, and it didn't flinch. And from inside, it saw something nobody had ever watched happen. As the eruption tore outward, it swept up the fine dust that drifts between the planets, cosmic dust, the leftover crumbs of the solar system, and pushed it along like a plow. The eruption acted, in the words of one of the scientists, like a vacuum cleaner, clearing the dust out of its path along a trail roughly 6 million miles long. People had theorized that this could happen for about 20 years. Nobody had ever seen it. You needed something crazy enough to be standing inside the explosion when it went off. And there was Parker, in the middle of it, calmly recording the whole thing. That's the difference between this mission and everything before it. We used to watch the sun's storms from a safe distance, like watching a hurricane on the news. Parker is the camera that flew into the eye, and it's still in there. Number 5, the dust-free zone. Here's something that sounds made up. There is a region around the sun where dust is not allowed to exist. Out in the solar system, space isn't truly empty. It's full of fine grains, dust shed by comets and asteroids drifting everywhere, the gritty residue of 4.5 billion years of things crashing into each other. It's basically everywhere you look, except in one place. Get close enough to the sun, and the dust just stops. For decades, theorists predicted there had to be a zone near the sun so blasted by radiation that any speck of dust drifting in would simply be vaporized before it could get any closer. A clean bubble, burned empty. But nobody had ever been close enough to check. Parker checked, and the bubble is real. There's a swept clean zone extending out something like 3.5 million miles from the sun, where the dust has been cooked out of existence. A pocket of the universe wiped blank just because it got too close to the light. And on the way in, Parker found other things in the dust the models didn't predict. Strange structures, rings, patterns. Nobody fully understands yet. But it's the empty part that sticks with me. We always talk about the sun as the thing that gives life, the warm thing, the reason anything here is alive at all. And it is. But get close enough, and it does the opposite. It doesn't just burn things, it erases them. There's a line you can cross out there, and on the other side of it, the universe is simply not permitted to keep its dust. Parker has been on the wrong side of that line, and come back more than once. Number 6, the edge that isn't a sphere. Quick question, where does the sun actually end? You'd think that's easy. The sun ends where the bright part stops, right? The glowing ball. But that's not really the edge. The real boundary is somewhere much farther out, and it's invisible. And until Parker, we'd never touched it. It's called the Alfvén surface. It's the line where the sun finally loses its grip. Inside it, the plasma is still held by the sun's magnetic field, still part of the sun, turning with it. Cross that line, and the material breaks free. It stops belonging to the sun and becomes the solar wind, racing outward, never to return. It's the true coastline of the star. The place where the sun stops being the sun. On April 28th, 2021, Parker crossed it. It dipped below that line into the solar atmosphere, and for the first time in history, a spacecraft had genuinely touched the sun, not flown near it. Touched it. The people running the mission announced it months later, and you could hear it in their voices. They knew they'd done something nobody had ever done. But here's the part that surprised everyone. That boundary was supposed to be a smooth sphere, a clean ball around the sun. It isn't. Parker crossed it, then crossed back out, then in again, because the edge is wrinkled. It has spikes and valleys, ridges and dips. The coastline of the sun is jagged and restless, shifting around like a shoreline in a storm. So the sun has an edge. We found it. And it's alive. And it moves, and we keep sailing in and out of it like it's nothing. Number 7. It saw the surface of Venus. This one's a little different, because the creepiest thing Parker did to Venus, it did completely by accident. To get close to the sun, Parker can't just point and dive. It has to slingshot, swing past Venus over and over, using the planet's gravity to drop its orbit lower and lower each time. Just routine flybys, borrow some speed, keep going. But on a couple of those passes, in 2020 and 2021, Parker had a camera pointed at Venus's night side. And Venus, as you might know, is wrapped in thick, permanent cloud. You're not supposed to be able to see the ground. We've spent decades unable to look at the surface of our neighbor with ordinary cameras because the clouds never break. Parker's camera saw through them anyway. It turns out the very longest wavelengths of visible light can sneak through those clouds, and on the night side, in the dark, the camera picked up a faint glow coming up off the ground. Not reflected sunlight. Heat. The surface of Venus is so hot it glows, even at night, even with no sun on it. Around 462 degrees Celsius, hot enough to melt lead, just sitting there in the dark, smoldering. And in that glow, Parker made out actual features. Continents, highlands and lowlands, showing up as darker and brighter patches because the high ground is a little cooler than the low ground. It was the first time an optical camera had ever seen the surface of Venus from space. Think about that. We sent a machine to study the sun, and on the way, almost as a side effect, it became the first thing to photograph the glowing skin of a hidden planet. Even its accidents are discoveries. That should tell you something about what it is we actually let loose out there. Number 8, the sun is slowing down. The sun spins. You probably never think about it, but it does. It turns on its axis the way the Earth does, just slower and stranger because it's a ball of gas and different parts spin at different rates. And it's losing that spin. Slowly, constantly, the sun is winding down. Here's how. Remember that solar wind, that endless river of particles streaming off the surface? Every particle that flies away carries a tiny piece of the sun's rotation with it, like a spinning skater flinging their arms out and slowing down, except the skater is a star, and the arms are made of plasma, and they're being thrown off into space forever and never pulled back. Bit by bit, that wind is acting like a brake. And now, for the first time, Parker is letting us actually measure the brake. By flying through the wind up close and mapping that invisible edge where the plasma breaks free, scientists can start to clock how fast the sun is bleeding off its spin. We're watching a star wind down in real time and putting a number on it. It won't matter to you. It won't matter to anyone for an unimaginably long time. The sun isn't going to stop spinning next Tuesday, but there's something quietly unsettling about it anyway. You grow up thinking of the sun as the one fixed thing, the constant, the thing that's just always there and always will be. And it isn't. It's running down, like everything else, like a clock nobody's winding. We just learned how to read the clock. Number 9, the closest pictures ever taken. For everything you've heard so far, you might still be picturing all this as numbers on a screen. Charts, data, scientists nodding at squiggly lines. So let me take that away from you, because in July of 2025, Parker sent home the pictures. Not artwork, not a simulation, actual images taken from inside the corona, closer to the sun than any camera has ever been. And what they show is a place. Streamers of pale plasma towering up like cliffs made of light. The solar wind, the thing we've been talking about this whole time, captured in the act of being born and pouring outward. And in some of them, you can see eruptions colliding. Two of those massive plasma clouds crashing into each other in a way nobody had ever watched up close. It looks like an ocean. A glowing, churning, alien sea. Except it's the outer atmosphere of a star, and it's millions of degrees, and it would end you in less than a heartbeat. It's beautiful in the way that the most dangerous things always are. The kind of beautiful that only exists in a place you could never, ever go. And we're looking at it. Right now, on screens on Earth, we can pull up a photograph of the inside of the sun's atmosphere. A place humans dreamed about and feared and worshipped for our entire history, and we have it in focus. We stopped imagining it. Here's the photograph. Number 10. When Parker dies. I want to tell you how this ends, because it does end, and it's coming. Parker doesn't get to retire. There's no plan where it slows down, comes home, lands gently somewhere, and gets put in a museum. It will keep diving. Every orbit falling back toward the sun, taking the heat, doing the impossible thing again and again. And the only reason it survives each pass is that it can keep that little 4.5-inch shield aimed perfectly between itself and the fire. That takes fuel. Tiny amounts to nudge itself, to hold the shield in place. And one day, not far off, that fuel runs out. When it does, the shield drifts. The sun gets around the edge of it. And the spacecraft, the fastest thing we ever built, the first thing to touch a star, the camera that flew into the explosion, the body of it cooks and crumbles in a matter of minutes. Out there, alone, inside the very thing. It spent its whole life trying to understand. And here's the part that gets me every time. The man it's named after, Eugene Parker, the one everybody doubted in 1958, he was still alive when it launched in 2018. 91 years old, watching the rocket carry his name toward the thing he'd been right about all along. He died a few years later in 2022. So the probe is going to outlive the man it was named for, and then it's going to die too. The same way. Into the same light. This was a video about a machine and the sun. It isn't, really. It's about us. About the fact that we built something brave enough to fly into a star, knowing it could never come back, just so we could finally understand the thing we've stared at our entire existence. Somewhere out there, it's still falling. Still working. Still sending back that one small tone to say it's alive. One day, that tone won't come. And there will be nothing on the other end but the sun, and the silence, and a name we threw into the fire.